Alright, so welcome back to the tutorial, and over here we look at whether POCOE is indeed true. So we're talking about pendulum and how when KE is converted to GPE and back to KE and back to GPE, this should go on forever as long as POCOE is true, right? And because of this, the pendulum should swing forever, but in reality, we of course do not see this happening. Every pendulum will come to a stop eventually. So is POCOE violated? That means could POCOE be wrong? POCOE can never be wrong, but let's investigate why. Alright, so as the pendulum swings, what happens is, in reality, it actually experiences frictional forces, for example, your air resistance, and this causes your kinetic energy to slowly be converted to thermal energy, which is then lost to the surroundings, so it's no longer with the pendulum. Now, because of that, the total amount of energy the pendulum has will be less over time. So there'll be less energy for the pendulum to swing back to its original height. So it cannot swing back to its original height. Less energy is available now. Now eventually, all the energy will be converted to thermal or sound energy. And when that happens, the pendulum has no more energy left on its own and it has to come to a stop. Now, why is it that POCOE still holds true? Well, it's because the total energy of the pendulum wasn't created nor destroyed. In fact, it was just completely converted to thermal energy. Alright, so it is not that the energy has been destroyed, it is just that all this energy, the GPE and the KE, is slowly converted to thermal energy as it overcomes friction or air resistance, in short. Alright, so the amount of energy it initially has will be equivalent to the amount of thermal energy that it releases to the surrounding. Now, for the next part, we are going to look at efficiency, and this is a pure science topic. So if you are from combined science, you can do one of these two things. Number one, you can either listen and learn as well, or number two, you can skip past this part. Alright, so what is efficiency, and why do we need to talk about it? Well, whenever there's energy loss, some energy that we put into a system will be wasted. So you can think of the total energy that you put into a system to be divided into two parts. Number one, you have the useful energy, and number two, you have the wasted energy. Alright, useful energy is basically energy that we desire, energy that we want out of an appliance or device or even a system. But wasted energy is basically energy that we don't want at all. Alright, so wasted energy usually takes the form of thermal and sound energy, and this is often lost to the surroundings. Alright, so one example is this. Imagine now you have your handphone with you. Alright, there are many things you can do with your phone, however the battery is left with only 3%. Now this 3% suddenly seems very precious, right? You want to use it to either watch the last few minutes of a drama, to send the last text messages to your loved ones, or even to just do your last TikTok. I don't know. Alright, but the desired energy or the useful energy that you'll consider is basically energy, the light energy that comes off from your screen, the sound energy that goes into your ears, but you realize that as you use your phone, it is also heating up. Now, this thermal energy is not something that you desire out of the phone at all, but nonetheless, some energy from the phone's battery will still be converted to thermal energy as long as your phone is working, right? But we don't want that heat energy, so that is considered the wasted energy. So whenever we calculate the efficiency of a device or appliance or system, we are comparing what is the amount of useful energy it has versus the amount of total energy that we put into the system multiplied by 100%. And that is what we have here. Now, a simple analogy to remember this is basically when your parents put in resources into your education, for example, that includes time and money, and how much of it you actually spend on your education is the useful part. But there are times when you channel the resource, which is the money, into other aspects that is not educational at all. So for example, spending it on maybe buying your favorite idols posters. Now these are considered wasted energy to maybe your parents. So in terms of efficiency, you'll be ranked lower. Alright, so this is just one useful way to think about it. Alright, but let's go on to the next example. So every second, a lamp is supplied with 10 joules of energy, and this is electrical energy. Now 3.2 joules is converted to heat, while the rest are converted to light energy. Alright, and we want to calculate the efficiency of the lamp in 1 second and in 1 minute. Okay, so there are two parts to this question. I'll bring you through. Now, first of all, we know that, so the total energy input for every second is going to be 10 joules, right? And 3.2 joules of this energy is converted to heat. Now, do we want heat from the lamp? Well, not really. The main energy source that we want is really the light energy. The heat is just a byproduct that we don't want. In fact, if this heat could be converted to light, it would be even better, right? So this is wasted energy. And the light energy is actually what we call the useful energy. Alright, so useful energy will simply be 10 minus 3.2, which is going to be 6.8 joules. And here we can calculate the efficiency, which is just going to be 6.8 useful energy over total energy, which is 10.0 multiplied by 100%, and you can get your answer. Now we'll do the same for the 1 minute case, and in 1 minute it just means that the total input this time will be multiplied by 60, so it'll be 600 joules. And for the wasted energy, it will also be multiplied by 60, so there'll be 192 joules. And alright, and what do you think the efficiency will be? Will it be the same as before, or will it be different? Alright, so hold that thought in mind. Now the total energy input will simply be 600 joules, and the useful energy, pardon my handwriting, will actually be 600 minus 192 joules, which will be 408 joules. Alright, and finally your efficiency will be 408, the useful energy over the total input energy multiplied by 100%. Now you should get back 68%. Now let's move on to question 2, and for such questions really is just about identifying what is the input energy, the useful energy, as well as the wasted energy. Alright, so a machine converts 2000 joules of electrical energy and 1000 joules of solar energy to some thermal energy, some sound energy, and some kinetic energy. Now, if the machine is designed to function as a heat source, what is its energy efficiency? Well, this time the purpose of the machine is actually to function as a heat source. So heat is what is useful in this case. So this is my useful energy. I'll label it with a U. And the rest are going to be my wasted energy. So I don't need the kinetic energy. I don't need the sound energy. Right? Now what about the solar energy and the electrical energy? Well, these are the energy that we input into the system. So in this case, my efficiency, I'm just going to do it straight away, will be equals to my useful output, which is my heat in this case, the thermal energy, 1200 joules, over the total amount of energy I put into the system, 2000 electrical, 1000 solar, multiplied by 100%, and you'll get the answer. Okay, you should get a 40% efficiency.